Welcome to my channel once again. In this video we'll be looking at the forward and reverse control operation of a direct online. In one of our previous video we talked about direct online, which is only used to control a motor in one direction. But in this video we'll be looking at how we can control a motor in both directions, forward and reverse. Sometimes a motor operation may be required to be reversed. Either a belt is stuck or something. There may be a need to reverse the motor. So what we normally do that is not advisable is to interchange any two cable, but that's not advisable. In this video we'll look at how we are going to incorporate a switch, a push button, whereby if a reverse operation is required, you just have to press the reverse button, and if a forward operation is required, you have to press a forward button. Alright, before I go ahead, I will advise you guys to, if you have not subscribed to my channel, do well to subscribe, for I have more interesting videos that will be coming out. So stay tuned to my channel for you to be getting these videos. So much, a whole lot of them, so interesting, especially for our friends in the industry, the industrial electricians. This will really help you. I will also give you the physical construction, not only the schematics or circuit diagram. Like this is the schematics and circuit diagram. I will give you the physical component arrangement. So let's look at the power section. You know, a direct online connection is made up of the power connection and the control connection, where this side is the power section and this is the control section. So for the power section, we have our incoming three-phase supply and a neutral entering into a breaker. This is our breaker. Now from the breaker it goes into two contactors. One is forward and the other one is reverse. So you know, for a reverse operation you have to interchange any two wires. Now let's look at how we interchange a two wire here. We have this cable. This is on the first phase. You can see it's now going to the third pole of the contactor. Look at it. This one goes into the first pole of the contactor, of the fourth contactor, and it also goes to the third pole of the reverse contactor. So you see, by so doing we have reversed the operation of the motor. When the reverse contactor is being energized, the motor will reverse. Now look at this. The second pole cable of the fourth contactor is same as the third, or is same as the reverse pole contactor of, okay. Then the third pole, you can see, is the same connection with the first pole of the reverse contactor. So we have reversed two cable here. So this is what you manually do by interchanging any two cable. So we have interchanged that. So all you have to do, if a forward operation is required, energize this contactor, and if a reverse operation is required, energize this contactor. So from there it goes to your overload. We know this overload is used to protect the motor, and the overload is being set at the motor current rating, so that whenever the current tends to supersede the motor current rating, the overload will trip. Now this is our motor, which could be in star connection or delta connection. I have talked about star and delta connection. You have to check my previous videos to get a video. Alright, so let's look at the control diagram. This is the control diagram. So let's look at how it works. Now the supply from the control diagram takes a supply from the first phase. You can take from the second phase, you can take from the third phase, but we are taking from the first phase. You can see This is a supply to the control operation network, and this is our neutral. You can see this is a neutral. This is our neutral cable. This is our neutral cable. See it, this neutral. Alright, so the first place the power cable enters is the normally closed terminal of the overload. You know why it is like that? So that whenever the motor trips, this place becomes open, deactivating the control network, meaning that the motor will not move, it will stop. You know, it's the control operation that detects or that controls the power section. So from the normally close of the overload, it goes into a stop button. Stop button is also normally closed, so that whenever you want to stop the motor, you have to open or deactivate this network. Once this contact is open, the operation stops. So from here, it goes to the input of the start button. Now we have to start button here. You can see this, you can see this. One is for the forward contactor, the other one is for the reverse contactor. Now see something, this is for the forward contactor, but you know, KM2 is the reverse contactor, while KM1 is the forward contactor. Why do we have this KM2 here? This is a terminal, is a normally closed terminal on the contactor. We do this so that we don't want two contactors to be on at the same time. What we mean is this: the forward and the reverse contactor should not come on at the same time. If they should come on at the same time, there will be an explosion inside the panel. So what do? We pass the forward contactor through the normally closed contact on the reverse contactor. The normally closed contact on the reverse contactor remains closed as long as the contactor has not been energized. So what this means is this: for the forward contactor to come on, the reverse contactor has to be off. And for the reverse contactor, this is the reverse contactor, for it to come on, the forward contactor has to be off. Once the forward contactor is off, this place remains closed, and if it is on, this place remains open, so that the reverse contactor will never come on. Now we know what this normally open contact is. We have said it before, is a returning contact. So you can see, so we have now our indicators. This is our forward run indicator, and this is our reverse run indicator, and this is our trip indicator. I will show you how this is being arranged in a panel. And this is our indicates that the motor is in a stop state, but here we're no longer using it as a stop, we are using it as a power indication light. So let me simulate this and let's see how it works. Can I simulate this? Let's see how it was. Alright, so you can see the phases has come live, but the breaker has not been closed. Let me close the breaker. Let's close the breaker. Look at the breaker. I'll click on it and it will close. It has closed. So you can see the power has gotten to our input side of our contactor, waiting for it to be energized. Okay, so if I press the start button of the forward contactor, it will run. If I press the reverse button of the reverse contactor, it will run. So depending on the direction of the operation. So let's press the forward. Let's see. Yeah, it's running. You see our motor is running. Look at the direction. It's going into an anti-clockwise direction, so it's running. and our contactor has closed because there is current in the coil. The coil has been energized, and you see our lights. You see our forward indication light is on, telling you that the forward contactor or the motor is in the forward direction or forward operation. So indicators are always necessary when you're building your panel, because it's not always time you have to open the panel to know what is going on. The indicators can help you, let you know what's going on inside the panel. So as you can see, if you want to start the reverse contactor, it can never start as long as the forward contactor is on. See, it can never start. It can never start because of this. This is open. For this reverse contactor to start, the forward contactor has to stop first so that this place will be closed. Now watch this place will become closed when I stop the forward contactor. Let me stop it. Stop it. You see, it becomes closed. You see, it becomes closed. So I can now start the reverse contactor. Let me start the reverse contactor. The reverse contactor is on. You see, it's on. And the forward contactor can never start. You can see. Let me try to start it. It can never start. Okay, so that's all for the forward and reverse operation. Now for the trip light, when I trip the overload, this light will come on. Let me trip the overload for the light to come on. If the overload, I've tripped it, the light is coming, it's on. So whenever, if you're at a distance and you see this light, it means that the overload has tripped. And what caused it to trip? The current, the motor tends to draw a current that is more than its stated rating. What could cause this? Maybe either the rotor encountered a kind of maybe the conveyor or the belt is stuck, or what is attached to the rotor is stuck, so it's now trying to apply pressure, draw current in order to be able to move it. So that's what could cause the overload to trip, when the motor draw a high current as a result of the load connected at the rotor side being excessively bigger, larger, or what it is driving. If it's a conveyor belt, maybe the belt is stuck somewhere, or there is a jam. All this can cause a current of the motor to rise. Or the bearing is bad, or the bearing of the motor is bad, or the windings of the motor is getting bad. So you just have to troubleshoot and know the real cause. Alright, I'll show you the physical arrangement, how it is being arranged inside the panel. So you just have to take note of these schematics and make sure you connect accordingly. Whenever you get your components, all these numbers, you see it. You see all these numbers. So make sure you connect it as it is. If you connect it as it is and press the forward button, it will run as it is supposed to. Now let's look at the physical arrangement. They are all the same. This is a physical arrangement, how it is being arranged inside a panel. You can see this side will be outside on the surface of the panel. This is the one that is inside the panel. This is how it will look like. So you can see our circuit breaker, the forward contactor, the reverse contactor, our overload, the motor terminal where it's being connected, and this is the terminal of the incoming supply. We have the trip light, power on light, stop button, forward light, forward start button, reverse light, and reverse start button. Okay, now let's see how this works. In our schematic diagram, we see that the control section takes light from the first phase. Let's look at that, how it's been arranged. see the first phase, and see this wire, see this one, see this one, so that is the power to our control section. See this, that's the power to our control section. That's this. See it goes to our overload. It goes to overload. You can see this is the normally closed contact of our overload. So this side has to remain closed if the overload is working, and it becomes open if it is stripped. Let's look at it the other side. You see, so it goes here. The light goes, the live wire goes here. See, the normally close of the overload, which is at 95. Do you see it? And also it goes at 95, and also goes to this wire, which is what, 97. So it goes to 95 and 97. So let's see. So it goes to 97, and here this is normally closed, so it could be here or here. I can connect this 97. I can connect, loop it to this. Why this wire will not come out from this, but it's the same thing as I connected it here and here. They are all the same thing. Alright, so the power on light also take supply from the first phase. You see it, this is the cable for the power on light. Take supply from the first phase. You see it, this is the first phase. Okay, now the output of from our overload, which is this, it goes to, let's see where it goes. It goes to, that's this red light. It goes to the input of the stop button. And let's look at it. The output of our overload, look at it. It goes to the input of the stop button. You see it. Now the output of the stop button goes to 4 terminals, which is the first terminal is the input of the start button, the normally open of the forward contactor, the input of the reverse button, and the normally open of the reverse contactor. So let's look at this. The output of the start button, which is this output of the start button, which is this red. We said it goes to this red one. Look at where it goes. This is the input of the forward contactor. This is one of the inputs. You see it. We say it normally open of the input of the forward contactor, and also where else did it go? Let's look at this input of the start button. That's correct. And another one, input of the reverse start button, which is this. We are correct. And another one, which is this. See very well, trace it. You see it. Normally open of our reverse contactor. So guys, they are all is just the same. You have to follow through the schematics. Once you follow through these schematics, do your connections, you will get it right. Once you press your start button, the forward contactor comes on, and once you press your reverse button, the reverse contactor comes on. The motor will be in a reverse operation. So you just have to follow this accordingly you will get it. So the coil of the forward contactor is coming from the normally close of the reverse contactor. We can still see this, the coil of the forward contactor. This is the forward contactor. You see this, there is 2 wires going into it. This is A1 of the forward contactor, which is this. You can see that there are 2 wires going into it. Look at it. This is the A1 of the forward contactor. We have 2 wires. One is the one coming from the normally close of the reverse contactor, and one is the one coming from the normally open of the forward contactor. So let's look at it. It's just the same. You have to follow this to do your connection. So let's trace one wire and see if it goes to the reverse contactor normally closed and the forward contactor normally open. So let's trace this. Let's trace one wire. Look at it. This one, this one, I'm tracing this one, this one, this one, this one, this one, tracing this, tracing this. So guys, you see, this is the normally open of the forward contactor. Now let's trace the other one to see if it goes to the normally close of the reverse contactor, which is this. Let's trace this. Let's see, guys. Let's see. You can see it, guys. It goes to the normally close of the reverse contactor. So just follow the circuit diagram or the schematics and you will get it right. Make sure you follow exactly what you have here. Follow what you have here. You will definitely get it right. I wish you good luck. I wish you success. It's all simple. Alright, so just stay tuned to my channel. I'll be giving you more and more interesting videos. We are taking it gradually. We will get to PLC. We'll get to HMI implementation, we get to programming, or you just have to stay tuned. I'll make it simple. I'll make the videos the explanations will be so easy to understand. Alright, thank you guys. See you.